Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday night math night. I'm so excited to be joining you tonight and for you to be joining me here for Math Wednesdays. Like Dr. A said, we are here every Wednesday night just going through a sample set of problems to help you prep for your upcoming exam. Like he said, we run the gamut from pre-K through 12. So I try to go over as much as I possibly can pre-K through 12. So without further ado, I'd like to know what test you're prepping for and where you're from. Where you're from is just fun. I like to know where my Wednesday night math people are from. I'm from Central Florida. I'm a math coach in Central Florida, and I am certified elementary ed leadership, and math 6 through 12. And 6 through 12 math is kind of like, I geek out when I get to do it. So I'm in the elementary schools, but I really like high school math. That said, I also like to know what test you're prepping for, because while the problems that I have tonight are set, it helps me take our rabbit trails in the correct direction. So, hello, all it says is Facebook user, so I don't know who you are, but you are prepping for Praxis Math in Alaska. Another one, Ocala, Florida. Welcome, pre-K through 3 math. Congratulations is all you have left. So we're going to go through about 8 to 10 problems tonight, and then we will close it out. So I'm so happy that you're choosing to spend your Wednesday night here with me doing math problems. So let's get started with problem number 1. Which statement about a triangular prism and a rectangular pyramid is true? Only the pyramid has triangular faces. The rectangular pyramid has an equal number of faces as the triangular prism. Only the prism has a triangular base. Only the rectangular pyramid has rectangular faces. These are the kinds of problems that often trip people up because it's not straightforward. It doesn't show us a picture of a rectangular pyramid and say, how many faces do you see? It's not giving us an equation and saying, solve. And those are the kinds of problems that a lot of us are more successful with because it doesn't require that critical thinking. It's these very wordy problems that trip us up because it's a lot more comprehension than it is actual math. So let's go ahead and break this problem down. Hi, Carmen from South Texas, math 4 through 8. Welcome. Go Cowboys. So with this kind of problem, we're looking at pre-K through 12. Pre-K through 3 kind of specifically. However, everybody needs to understand the format of a geometric shape, especially a 3D shape, because when you go to solve surface area, volume, all of that, if you don't understand the basic foundations of a prism and a pyramid, you're going to struggle with those kinds of problems. So let's break down the difference between a prism and a pyramid. So we have prisms and we have pyramids. Prisms are going to be more like your boxy shapes, I guess, if you will. A prism has 2 equal bases with rectangles surrounding it. So if it's a rectangular prism, we're going to have 2 rectangles as our base, and then we're going to have rectangles surrounding it. If we have a triangular prism, we're going to have 2 triangular bases and then rectangles surrounding it. If it's a hexagonal prism, we're going to have 2 hexagon bases and then rectangles surrounding it. A pyramid is going to have 1 base and then triangles extending up, connecting at 1 vertice or 1 vertex. So let's take a look at what these would look like. So a prism. If I had a triangular prism, I would have 2 triangular bases. Don't think of a base as what the object is sitting on, because unless they draw the object standing up, sitting on that base, that's not going to be the base. Here I have a triangular prism, and it's sitting on one of those rectangles, but the triangles are actually our bases. It's a triangular prism because we have 2 triangular bases and then rectangles surrounding it. How many rectangles am I going to have? I'm going to have the number of rectangles is going to equal the number of sides on my base. So this triangular prism is going to have 3 rectangles, 1 for each of these sides. A pyramid, a triangular pyramid is going to have a triangular base, and then it's going to have triangles extending from those sides up to a vertex. If I had a rectangular pyramid, I would have a rectangle base, and I would have triangles extending from those sides up to a vertex. So that's the difference between a prism and a pyramid. Now, we're looking at a triangular prism, which I drew right here, and a rectangular pyramid, which I drew right here. Let's take a look at these statements and see which one is true. Hey, Hope, good to see you. Only the pyramid has triangular faces. Well, the pyramid does have triangular faces. However, the prism has triangular faces as well, only because it's a triangular prism. And so we have 2 triangle faces. If it was a rectangular prism, we would have no triangles in our prism. So in this case, that's not true, because not only the pyramid has triangular faces. The rectangular pyramid has an equal number of faces as the triangular prism. So how many faces does this guy have down here? We have 1 base, plus we have 4 triangles, 1 for each side of my rectangle, which equals 5 faces. Up here we have 2 bases plus 3 rectangles, 1 for each side of my triangle, which equals 5 as well. So does the rectangular pyramid have an equal number of faces? Yes, that is true. Only the prism has a triangular base. The prism, that's true too. Only the prism has a triangular base. Well, that's true too. Only the rectangular pyramid has rectangular faces. That's not true because we have a rectangle here and then we have rectangles over here. So I don't know what I was trying to do with that letter C. I wrote this problem and that should have said both of the prisms have triangular bases, which would have been false. But in this case, we have 2 right answers. And you know what? Some of your exams are going to have 2 right answers. I hate to break it to you. It'll say which statements if it has 2 right answers, but some of your exams are going to have 2 right answers. It depends on the exam. So there we go. We have 2 right answers for this problem. Let's move on to number 2. A picture is to be printed onto a sheet of paper with dimensions of 8.5 by 14 inches. A margin of 0.75 inches is to be left on all sides of the picture. What is the area of the printed picture round to the nearest tenth? This is not a problem I'm going to try to do in my head. This is a problem I'm absolutely going to draw out and solve. You've got this. You can do it. Pre-K through 3 math on Saturday. I believe in you. So make sure you look at that blueprint so you know exactly what skills you're covering. Well, my iPad just decided to turn off, so we're just going to keep talking about this problem, and that's okay. So I'm going to draw a picture of this piece of paper. When I draw a picture of this piece of paper, there we go. When I draw a picture of this piece of paper, I'm going to label it. So we have 8.5 by 14. So this is going to be my 14-inch side, and this is going to be my 8.5-inch side. And then it says, what is the area? Well, we know area equals length times width when we're dealing with a rectangle. However, they gave us some more information. We're not just going to multiply 8.5 times 14 because the picture can't print all the way to the edges of the paper. So what they told us was we have to leave a margin of 3/4 of an inch on all sides of the picture. Now, if it said just on the top and the bottom, well, we would have to know which one is the top and which one is the bottom. Would this be the top or would this be the top? And they would define that for you. So if it just said the top and the bottom, then we would subtract differently. But this is all sides. So that means that my picture is actually going to be here. And I'm trying to figure out that area. Well, I know that I've got a margin of 0.75 on all sides. That means that this is 0.75, and this is 0.75, and this is 0.75, and this is 0.75. So how am I going to figure out this dimension? How am I going to figure out the length of this? I'm going to do 8.5 minus what? I'm going to do 8.5 minus 0.75 minus 0.75. This is where a lot of people are going to make their mistake. They will only subtract 0.75 one time, not twice. but you have to account for the 0.75 that's up here and down here. So then we've only got this section in here that we're dealing with. And the same thing is going to happen for the 14. So I'm going to take this over here and go 8.5 minus 0.75. Now, could I use a calculator? Absolutely. However, not everybody gets a calculator. I don't think my pre-K through 3 people get a calculator, or my K through 6 people. I can't remember, but I don't think. GK math absolutely gets a calculator. So I'm going to go ahead and solve this. You'll notice I did not do this. Why did I not do that? That's another common error that's going to happen. That's not going to work because I'm not subtracting the right units. When I'm subtracting or adding decimals, I have to line up the decimal. Think about it this way. Think about it with money. If this was $8.50 and I was subtracting 75 cents, I need to subtract the cents from the cents. But in this example, I would be subtracting $8 minus 70 cents. That just doesn't make sense. So I have to make sure $8 minus 7 dimes, and then that just doesn't line up. So I have to make sure that I'm subtracting and adding the correct place value. So borrow a 10, carry the 1, 5, borrow $1, carry the 1, 7, 7.75. Now I have to do that again to account for this 0.75. So 7.75 minus 0.75, well, that's easy. I'm going to get 7.00. So this side is now going to be 7.0. I'm going to do the same thing for that 14. So I'm going to do 14 minus 0.75 minus 0.75. Yes, I'll explain that again in 1 minute. This is not 1.75. That's 0.75. I just drew that line to show the line. So 14.00 minus 0.75. I'm going to have to do a lot of borrowing in this case. 5 to 13.25. And then I'm going to subtract that 0.75 again. 3, 2, 12.5. So this side is 12.5. I'm actually going to check my work with my calculator, even though not everybody gets a calculator, just to make sure before we move on. All right, perfect. And 14 minus 0.75. Perfect. Now that I have the dimensions of the actual ink, now I can find my area. So now that I have the dimensions of my ink, which is this section right here, 7 and 12.5, now I can do 7 times 12.5. And again, and when I'm multiplying, I don't have to line up my decimals. So I'm going to put 12.5 up here times 7. I don't have to do 7.0 because that 0.0 doesn't matter. So 7 times 5 is 35. 7 times 2 is 14, 15, 16, 17, 7, 8. Now, because I have one decimal value here, I'm going to have one decimal value in my answer choices. So my answer is going to be 87.5. I had someone ask, why aren't we doing 8.5 times 14? Excellent question. We are not doing 8.5 times 14 because we have a margin all around the paper that is going to be left with no ink. And they want to know the area of the picture only. So we have to take that margin into account, which is that white space around the photo. As I'm working, if you have any questions, please ask me because I'm more than happy to answer them while we're in the moment because it's going to help everybody else as well. All right, problem number 3. two angles are supplementary. One of the angles has a measurement of 76 degrees. What is the measurement of the other angle? 14 degrees, because the sum of two supplementary angles is 90 degrees. 104 degrees, because the sum of two supplementary angles is 180. 284 degrees, because the sum of two supplementary angles is 360 degrees. 76 degrees, because supplementary angles are congruent. This right here is completely a vocabulary problem. This right here is completely a vocabulary problem. If we understand our geometry vocabulary, then this problem is super simple. But if we don't understand our geometry vocabulary, then this problem is really going to give us a run for our money. So let's talk about the vocabulary that we see in this problem. Two angles are supplementary. There's some vocabulary. One of the angles has a measurement of 76. What is the measurement of the other angle? So angles have two rays and they're connected by a vertex. There's an angle. Angles can be acute, obtuse, or right. That's just a little bonus piece of information for you. Doesn't have to do with this problem, but always helpful to have little bonus tidbits of information. One of the angles has a measurement of 76. So I know that that's an acute angle because it's less than 90. But what does supplementary mean? If I don't know what supplementary means, this problem is automatically out. If you don't know what that vocabulary is, you're not going to be able to solve this problem. So supplementary means has a measurement of 180. Supplementary angles add up to 180 degrees. On the flip side, complementary angles, spelling is not my forte, add up to 90 degrees. So when I look at these answer choices, I don't even have to solve it if I know my vocabulary. When I look at my answer choices, I don't even have to solve it because if I know my vocabulary, already I know the sum of two supplementary angles is 180 degrees. Bam, there's my answer. So they didn't, what should have happened is they should have had two answer choices with that so that at least you had to solve. At least you would have had to do 180 minus 76 and you would have gotten 104. But why waste your time doing that? And I promise you, so many people are going to waste valuable testing time doing this because they're not going to read the answer choices. They're going to read the problem and it's going to say one of the angles has a measurement of 76 degrees. What is the measurement of the other angle? And you know what they're going to do? They're going to sit and they're going to say, I know that supplementary is 180. And so they're going to solve it, wasting valuable time when you look at the answer choices, there's only one answer choice that can possibly be true. Because the sum of two supplementary angles is not 90 degrees. That's automatically out. The sum of two supplementary angles is not 360 degrees. That's automatically out. And supplementary angles are not congruent. So B is the only answer choice that's possible. Now, if they had said, if there were multiple answer choices that said, 104 because the sum of two supplementary angles is 180, 106 because the sum of two supplementary angles, then you'd actually have to do the math. But don't do the math if you don't have to. Let the problem speak for itself so that you can save that valuable time. All right. What is the measure of angle B. What is the measure of angle B? Already, I'm going to cross off one of my answer choices. Does anyone want to be brave and tell me which answer choice am I going to cross off right away? I'll give you like 2 seconds. Thinking in your head. I'm going to cross off D. Why am I going to cross off D? Because yes, excellent job. Because all of the angles in a triangle have to equal 180. And an 180 degree angle is a straight line. That equals 180 degrees. First of all, B is not a straight line. And second of all, angle A plus B plus C has to equal 180 degrees because all of the angles in a triangle have to equal 180 degrees. No matter if it's an isosceles, a scalene, a right triangle, no matter what. And if you don't know that vocabulary, you better learn that vocabulary too. So now that I know that, first of all, D is wrong, and that A plus B plus C has to equal 180, I'm literally going to set up that equation. I'm going to set up A plus B plus C equals 180, and I'm going to show you what we're going to do next. So 87, because A is 87. B is 2x minus 4. C is 5x minus 1. And that all equals 180. Don't overthink it. People think that they can't do something like this because there's expressions and they're not real numbers. You can absolutely set this up because all we're doing is setting up an equation that we can solve. So now I'm going to combine my like terms. I'm going to combine the things that are alike. I cannot just add all of this up because x's cannot be added to normal numbers or integers. So I'm going to add my whole numbers up or subtract, and then I'm going to add or subtract my x's. So 87 minus 4 minus 1. 87 minus 1 is 86. 86 minus 4 is 82. Plus 2x plus 5x equals 180. Now I'm going to do my x's. 5x plus 2x is 7x. So 82 plus 7x equals 180. Now what am I going to do? At this point, we're just solving an equation. This really has stepped really far away from geometry, and we're just solving an equation together. I'm going to subtract 82 from both sides because in this moment, my goal is to figure out what x is. Why is my goal to figure out what x is? Because if I figure out what x is, then I can figure out what that angle is. So I'm going to subtract 82 from both sides to get that x by itself. 82 minus 82 is nothing. Whatever I do to one side, I have to do to the other because it's like a balance. So if I have a scale balance or a pan balance and I add 2 M&Ms to this side, I have to add 2 M&Ms to this side, or that balance is going to be off balance. So I like to think of this triangle as my equal sign, and whatever I do to one side, I have to do to another. If I add 82 to this side, I have to add 82 to this side. If I multiply by 2 on this side, I got to multiply by 2 on this side. So 180 minus 82 is going to be 98. 7x equals 98. I'm going to cross-check that with my calculator just to make sure. Certainly don't want to mess that up. Yep. And then I'm going to divide both sides by 7. Again, some of you will have a calculator, some of you will not. I'm going to use my calculator because I have it right now. But if you don't get a calculator, good old-fashioned long division works too. X equals 14. Now, here's what I'm shocked by. I'm shocked 14 is not an answer choice up here. but 14 is not the answer. Why is 14 not our answer? We solved it. We did all the work. It's not the answer because that's not what it asked for. It asked for the measure of angle B. Well, angle B is this whole thing. So now step 2 of this problem is to take my expression that equals angle B and plug X in for it. So 2 times 14 minus 4 equals angle B. 2 times 14 is 28. 28 minus 4 equals 24. So angle B equals 24 degrees. Now, it kind of looks like it's 24 degrees, but we never, ever, ever, ever base geometry on looks. Oftentimes, they will draw pictures not to scale on purpose to make sure you're doing the math and not just, and that you're not like using just your eyeballs to figure it out. So often people will see a shape that looks something like this, and they'll say, well, this angle is 90 degrees automatically, and it's not. It might be 87 degrees, or it might be 102 degrees. Do not assume that things are the way they are with just your eyes. That is critical in my math 4 through 8, 5 through 9, or 6 through 12 exams, or 7 through 12, depending on where you're taking it. It is not always the case based on what you see. You have to prove it with your math. So even though this looks like the smallest angle, we're certainly not going to just pick that answer unless we're running out of time. And at that point, we're just picking answers to move on. So let's go ahead and move on. I had to get on my soapbox for a minute because I don't want you guys to make a mistake of just choosing that answer when you have enough time to solve the problem. All right. What can we conclude about the lines that are graphed to the right? Line T does not have an x-intercept. Lines P and T are intersecting lines that are not parallel or perpendicular. Lines P and T are parallel. Lines P and T are perpendicular. So in this case, we could know a lot about lines, but again, if we don't know that vocabulary, it's really, really, really going to hinder us. So let's take a look at the vocabulary that we've been given before we go into what we know. X-intercept, parallel, perpendicular, intersecting lines. Those are the 4 key words that we see. So let's talk about that together. Would I sit here and talk about this in my head if I was taking this test? No. But I'm trying to give you as much information as possible so that you're ready for your exam. So, intercepts. X-intercept is where your graph, in this case, your graph is a line. But my 4 through 8, 5 through 9, 6 through 12, 7 through 12 people, they're going to have graphs that are look something like this, or like this, or like this, or like this. So the x-intercept is where any graph, the graph, crosses the x-axis. So what do you think your y-intercept is going to be? Exactly right. It's exactly where the graph crosses the y-axis. So this is our x-axis. This is our y-axis. So where the graph crosses that x-axis is going to be your x-intercept. So in this case, line P crosses the x-axis right there, and it crosses the y-axis up here. Line T crosses the y-axis right here, but it doesn't cross the x-axis. Does that mean that line T does not have an x-intercept? Does that mean we've already found our answer? No, because lines go on forever and ever and ever. If this was a line segment without arrows on the end of it, and it said it was a line segment, which means it has ending points, then yes, we could say line segment T does not have an x-intercept. But this is not a line segment, it's a line, which means it's going to go on forever and ever and ever, which means it's going to eventually cross that x-axis, which means it's going to have an x-intercept. So A is out. Now, at this point, we have to decide if these lines are parallel, perpendicular, or neither, because all of the other answer choices are referencing parallel, perpendicular, or neither. Well, how do we figure out if they are parallel, perpendicular, or neither? Well, we know they're not parallel. Why? Because parallel lines, let me switch colors here. Parallel lines, what? What do we know about parallel lines? Parallel lines never intersect. What else do we know about parallel lines? They have the same slope. So parallel lines never intersect and they have the same slope. Well, these lines definitely intersect. They intersect right there. That's where they intersect, which is where they cross. So parallel lines never intersect. So lines P and T are parallel. Not true. So now we have to figure out, are these lines perpendicular or are they just intersecting lines that aren't parallel or perpendicular? What do we know about perpendicular lines? Perpendicular lines have negative reciprocal slopes. That means that if line P has a slope of A over B, then line T is going to have a slope of negative B over A. We're going to flip that slope and negate it. So if line P has a slope of A over B, then line T is going to have a slope of negative B over A. Negative and then reciprocal means we've flipped them upside down. So that said, we've got to figure out the slopes of these lines to figure out if they're perpendicular or to figure out if they're just intersecting. So how do I find the slope of a line? I'm running out of space on my piece of paper here. Slope of a line is going to be rise over run. Let's go ahead and change colors again. Slope equals rise over run. If I'm given a graph, I'm going to sit and count it because that's going to be the easiest way. So I'm going to find 2 points. So let's see. Let's erase these dots. I'm going to take this point and this point for line P. And for line T, I'm going to take this point and this point. So rise over run. So I'm going to rise for P. I'm going to rise 1, 2, 3, 4 to get to my next dot. 1, 2, 3, 4. And I'm going to run -1. Why is it -1? Because I'm going left. Going up is positive. Going down is negative. Going left is negative. Going right is positive, just like on a number line. Now, could I have gone the opposite? Could I have gone from this dot to this dot? Yeah, let's try it. 1, 2, 3, 4. So that would be -4. And then I would be running a +1 because I'm going to the right. Still -4. So line P has a slope of -4/1. So P -4/1. Now let's find the slope of line T using the 2 dots that we have for line T. The 2 dots that I have for line T, and I should probably change those colors so we know that we're not using the same dots. I'm going to rise 1, and I'm going to run 1, 2, 3, 4, +4. Could I have gone the other way? Yes. Rise -1, run -4. Negative divided by a negative is a positive. So I'm still going to get +1/4. What do we notice about these two slopes? They indeed are negative reciprocals. One is a negative, one is a positive. That's our first clue. And then the numbers are literally flopped. So these lines are perpendicular. They are not just intersecting that are not parallel or perpendicular. So D is the correct answer. Another linear equation problem. Which of the following graphs represents the system of equations below? Now, this problem is really difficult to do within the format that they gave us. Why? Because standard form is not helpful. Linear equations have multiple forms. Linear equations come in standard form, slope-intercept form, and point-slope form. Standard form is AX plus BY equals C. Slope-intercept form is Y equals MX plus B, where M is your slope and B is your Y-intercept. I know, mathematicians are not very creative when they come to naming things. Slope-intercept form. Point-slope form is Y minus Y1 equals M times X minus X1, where M is your slope, and Y1 and X1 are a point on your line, hence point-slope form. Standard form gives us nothing. So we have to manipulate these equations to solve for Y. I want you to pay attention to that because while in this problem we are solving for Y, sometimes in other domains, they'll say, solve the equation for H, solve the equation for G, and they'll give you an equation and you just have to get that variable by itself. So if you see something like that, don't let it overwhelm you. So let's go ahead and solve each of these equations for Y and put them in slope-intercept form. Because if we have it in slope-intercept form, then we can immediately spot our Y-intercept, which will help us eliminate one of these answer choices. So we have 2x minus 3y equals 6. Solve for y. So I'm trying to get y by itself. So I'm going to subtract 2x from both sides. And I'm left with a negative 3y equals negative 2x plus 6. Why didn't I say negative 3y equals 4x? Because I can't do 6 minus 2x. I can't do 6 minus 2x because they're not like terms. So I'm just going to leave it. Why did I write negative 2x plus 6 instead of 6 minus 2x? Because in slope-intercept form, the x's first. So I'm going to try to keep it as consistent as possible. Divide both sides by -3. And when I divide both sides, that means divide everything by -3. So I have y equals -2 divided by -3 is just +2/3 x. 6 divided by -3 is -2. I'm going to leave that one there, and then I'm going to go ahead and solve the other one. So let's go ahead and solve the other one. Actually, you know what? Let's not. Let's look at our answer choices and see if there's any answer choices we can eliminate. So I'm looking for a line that has a slope, or not a slope, a y-intercept of -2. Does this graph have a line that has a y-intercept of -2? 1, 2, 3. Nope. Is there no line the y of -2? Let's see. And does not slope 2/3. See. Rise 2, 1, 3. That could be our winner. Let's look at C. -2. No goes through that dot. So C. D. 1, 2. No line goes through that. So would you look at that? The only answer as y and a slope of 2/3. How awesome is that? So without even manipulating this equation, we just found our answer, and we just saved ourselves minutes on this exam. Make sure that you are using these testing strategies and using your answer choices to help you. Now, I'm going to show you how to manipulate that just so that you have extra practice with it. But on the test, I wouldn't. A, C, and D are very obviously not the answers. And so I would be done with this problem if I were you. 4x plus 5y equals 25. Subtract 4x from both sides. Remember, I'm going to keep that x out front. So 5y equals -4x plus 25. Divide by 5. And I get y equals -4/5 x plus 5. So then I would obviously cross-check and make sure. But again, in this case, I'd be done. I would not solve that problem after looking at my answer choices and figuring out that B was the correct answer. All right. If the sum of this symbol and this symbol equals 8, and the equation below is true, what is the value of U plus 5 capital fancy M? I don't know what those are called, so we're going to call it fancy M. I know that U has a name. I just can't remember what it is. So, again, please do not get overwhelmed and stressed out because you've never seen something like this and something like this. Don't start thinking all crazy things like, oh man, I didn't study that. You don't need to. Do you know what the word sum means? Answer to an addition problem. So, the sum of U and M equals 8. So we know that's true. And we know that's true. So we can use a system of equations to solve. So here's what I'm going to do. I'm going to distribute this through. So I'm going to go ahead and distribute the 3 through. Distribute means we're using the distributive property to multiply the 3 through everything in the parentheses. So I'm left with 3u minus 6m equals 15. And I also know u plus m equals 8. Now, I could use substitution or elimination to solve this. I'm personally going to use elimination because elimination is my favorite, but you could very easily use substitution. In fact, I'll show you how to use both. So I'm going to multiply this by 6. As long as I multiply everything by 6, it's fine. So I'm going to end up getting, I'm going to keep this, and then I'm going to put this here. I'm going to get 6u plus 6m equals 48. Do you see why I multiplied by 6 now? I did that so that when I add these equations together, that goes away. 3 plus 6 is 9. 48 plus 15 is 63. Divide both sides by 9, and little u equals 63 divided by 9 is 7. If u is 7, what is m? 1, because 7 plus 1 is 8. Exactly. So I'm going to go back up here and use my understanding of what that is. If little u is 7, 7 plus m equals 8, m is going to equal 1. So u equals 7. Whoop, that was very sloppy. M equals 1, but I'm not done, and you'll see that 1 and 7 are answer choices. That's not my answer. They want to know, what is the value of u plus 5m? So now I have to take what I've just learned and plug it in. U is 7 plus 5, m is 1. 7 plus 5 is 12, so my answer is 12. Don't jump ahead just because you got an answer. Allow the problem to carry you through. Figure out what the problem is asking you before you just choose an answer. Now, I said that I could also solve this using substitution. Let's go ahead and solve this using substitution. Because what I did over here was elimination. Let's use substitution. So I have 3u minus 6m equals 15. And I have u plus m equals 8. I'm going to subtract m from both sides. So I'm going to get u equals 8 minus m. Now, what can I do with that? Well, if I know that u equals 8 minus m, or u is the same as 8 minus m, I can take this expression and plug it in for u. So I can now say that 3 times 8 minus m minus 6m equals 15. I substituted something that was the same as u in for the u that was in that equation. Distribute. 3 times 8 is 24 minus 3u minus 3m, I'm sorry, minus 6m equals 15. Negative 3 minus 6 is negative 9, so 24 minus 9m equals 15. Subtract 24 from both sides. I get negative 9m equals negative 9. Divide both sides by negative 9, and I get m equals positive 1, because a negative divided by a negative equals a positive. That's the substitution way. Now I could take that, plug it back into here, and figure out that u is 7. So, like I said, multiple ways to solve the same problem. We can use elimination or substitution to solve this problem. any questions about the problems that we've solved tonight? We are actually rapidly running out of time. I'm going to go ahead and post the link to tonight's slides. There are 3 bonus problems at the end that we will solve next week. So we did not get to solve the last 3 problems. I will solve those at the beginning of next week's session. But if you want a link to these problems so that you can solve these problems on your own or practice or just have an extra link to problems, here is the link to the problems tonight. If you don't have any questions, that is amazing. If you do have questions, please ask me. That's why I'm here. If there's something that you want me to focus on, please let me know. So if you're like, man, I really wish you would have done more problems on blah, 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 please post them in the comments. I use those comments to help me build the problems for the following week. So let's go ahead and turn it back over to Dr. A, as he did say that he wanted to come back, close this out, and he had a special surprise for you. And I will see you all next Wednesday.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.